So we can start, right?
I believe so, sir.
Okay, fine. So today I have taken one section for installing Kubernetes on self-host machines. Okay, we already covered the Kubernetes installation part and configuration part, but that is related to manage EKS or manage Kubernetes service that provided by specified cloud providers. So in our case, we install EKS, I mean configure and deploy application EKS, Elastic Kubernetes Services. So that services provided by Amazon Web Services. Okay. Same way, other providers also share, I mean, provide Kubernetes services like EKS, AKS, GKE. So coming to on-premise or self-hosted, we are the one who need to install control plane and the data plane. I mean, worker node and master node. Okay. So we spin up the machine and install master node components and worker node components. Okay. Go to scenario, right? So here we can uh, consider one of the manager services, EKS. That is for AWS Elastic Kubernetes Services. Okay. So coming to self-hosted, we are the one go manually install each components and configure. Then we deploy the application. Okay, we can add as per our need. I mean, for example, there is two nodes. First we add, then we can add more nodes. Okay, as per our need. So today we are going to configure self-hosted Kubernetes cluster with the help of a tool called kubeadmin. Okay, kubeadm. This is the parts. Okay, like this is master and this is worker. In our case, I will configure single machine when there is one node only. Okay, and here the components there. Okay, I mean API server, etcd, then scheduler, controller, all things there. This is a previous scenario. Okay, I mean manage a cluster. We already configure all the things like master part and worker part. All manage. I mean configured. I mean installed by Kubernetes. So sorry. the EKS. EKS, I mean, AWS is managed that EKS service. So with a single command, it will automatically configure all things and we will get the Kubernetes cluster. I mean the EKS cluster. So here we are going with the kubeadmin. Okay, kubeadmin. Kubeadmin is it is a tool actually. It is a tool that for designed to help bootstrap our Kubernetes cluster. That's a primary role of kubeadmin, and it's also a part of Kubernetes project. Okay, mainly I mean commonly used for setting up setting up the Kubernetes cluster and managing, initializing cluster, then joining this cluster with the other nodes in the cluster. Okay, so all the things managed by the kubeadmin. So I am removing the old part in case. So when we configuring self-hosted Kubernetes cluster, there is some prerequisites. One, the master machine have at least two virtual CPU and 2 GB RAM. Okay, not 2 GB RAM, 4 GB RAM. Then the second one, yep, at least we have two machines. Then some security ports we need to enable, okay, for communication between master node and the worker node. So some security ports there. These are the prerequisites, okay. So the ports numbers, these are the ports numbers. So for the master node, we need to enable TCP port number 6443. That's for Kubernetes API server. Okay, the API server communicate with this port number. Then, then again we need to add port number starting with the 23792 So in between there is so many ports there. So all ports we need to enable. That is for etcd client, etcd server client API connection. Then TCP 102.574, that for the Kubernetes API. Same way, 102.102.594 Q scheduler, then 2574 controller, 22 for SSD connection. So we need to access the machine and manage the machine. Then UDP 8472, that for cluster wide network communication. Communication means there is a network we need to create. Okay, for what? The communication between master node and worker node, we need to create a network. So we are using, there is so many network services there like Calico. Here I am using Funnel VXLAN. Okay. So coming to worker node virtual machine, we need to enable these four ports. The first port for same Kubernetes API, So these both can communicate via API. Then for coming to worker node, we need to enable some more ports, okay, for exposing our application and so many containers ports are there. Okay, we need to assign IP for each one. I mean, not IP port for each one when I mean using the node port service. Okay, so that we are enabling from 3000 to 3000, not the 30,000 to 30,000 27, like these ranges for we are enabling for the worker node. And same way 22 for SSH and UDP for cluster wide network connection. So the best way, we need to create a security group, okay, manually. I believe I have already create both groups. I will check. It is AC2. Then go left side, we can see the security groups. Under network and security, there is a security group. Click security group. All time we are going with the default security group. I mean, when we creating any virtual machine, there is automatically create a security group. Okay. So yeah, here I already created two security group, one for worker node and one for master node. So I'm just opening. These are the ports I am enabling here. All are inbound ports. Okay. For SSH I am enabling. Then this is for yes. These four master part. Okay. So all ports are I enabled as per the list. 64 is there. 2379 starting from there and ending with the 238880. Then 259 there. 259, yes. 84 there. 8472. Yep. All done. Same way I configured. I mean, create one security group for worker node. So why we create security group before means when we configuring virtual machine, we can assign the existing group. We can choose this group. That's all. So this is a worker node security group.
Can I ask you a question?
Yes.
Did you just created this port numbers or you created it before you start the class?
Yes, we can create the security group and just assign the security group to the corresponding machine. That's all. When we
Okay.
create. Yeah. Okay, for worker node, I am enabling these ports. Okay. Uh, Here there is a port number starting from 30,000 and ending with 30,000 and that series. So in between we got so many ports. Okay, like around 2000 something ports there. So we can use that 2000 port for enabling node port. And SSH, then API. This is API and this is for the network communication. So the network parts is done. Okay, so then we need to choose the machine and make it. I mean, there is at least two machine there. We need to create a Kubernetes cluster. So go to launch machine. Name it as master. Using Ubuntu. Change the configuration type to T2 medium. Here you see firewall security group. So in this case, is by default it will create a security group. The name is secure launch wizard one. So here we need to choose select existing security group, and the common security groups are listed here. Just to drop down. Yeah, the master. In our case, master is be configured, right? So choose master. So that is done. Everything is done. Okay. Yeah, we can deploy. I mean launch machine. So the same way, I'm going to install my worker node. Okay. When we creating a Kubernetes cluster, make sure uh, all machines VPC is same. Okay. So here I am choosing existing one. Worker. So it will attach and launch instance. Okay. So copy the IP, copy the master IP, and open a terminal. I'm using Visual Studio Code. Okay. So simultaneously, I can access both machine. Which tool? I mean Kubeadmin, right?
No, no, sir. I think you're using this visual, what do you call, so that you can
Yes.
access both master and worker at the same time, right? What's the name of this one?
This Visual
It's
Studio.
I think we need to download and install it into our machine, or it comes with the default.
No. We need to download.
Okay, VS Code Visual
This
Studio
is
Code.
this is the application.
Oh, okay. Thank you, sir. I'll
Yeah.
make a note of it.
I mean, using Visual Studio Code, we can access all things. For example, This is my production machine. Okay, just I will show you. This is my Kubernetes cluster. Just clicking the Kubernetes cluster. We need to install the plugin. Okay. You see, there is two cluster. So here we can do all the things using Visual Studio Code. So many plugins there. As per our need, we need to add the plugins. Okay. So here I can add more terminals. I mean, in this case, I only enable two terminal. I can add more. So just go back and now I copy the pub worker node IP. Okay. Okay, both are done. Now I am just go to sudo. I mean root, then change the host name. So I mean we can see the machine name. This is master. Okay. Okay. One is master, one is worker node. So apt update. Okay. So I have one repository, okay, to install this thing. I mean, in that repository, there is a script, so we can easily install all the packages using that script. So this is the script directory, I mean repository. So here we are going with the script. So in this script, there is two script there. Okay, one is for common and one is for the master. So we need to run this common script in all the machines. If we have, in our case, there is two machines there. For example, three or four or five machines there, we need to install the common script in all the machine. So what are the things inside the common script? We will explain. So this is a bash script, okay? So here the line 9 is the version of the Kubernetes 1.2.8. That's the latest version of the Kubernetes. Then we need to disable the swap memory. Okay. So the line 12 is for disable the swap for each node. Then keep the swap off during the reboot. Sometimes after, I mean, we disable swap, but after reboot the machine, again it will, I mean, the swap is enabled. So line 15, we create a cron job. Okay. So the cron job will verify if the swap is enabled. If enabled, it will automatically disable, I mean, using the cron. Then this is installation of CRIO runtime. That means for running a Kubernetes cluster, there is a container technology there, right? I mean, any containerization tool there, like Docker or container runtime, container D. So not container D, container runtime, container D. Okay. So here we are installing container runtime, and the container runtime version is 1.2. It's the same as the Kubernetes version. Then this part are creating config file to load the module at the boot up. This is for the networking part. Okay. Create a IP table in our machine. So using the IP table, each machines can talking via a bridge. Then this is a downloading Kubernetes components. I mean, this is a key, and after it will automatically fetch the full package from the kubernetes.io. That's the directory. I mean, that's a repository where the components are belong. So when we running the entire script, the script will do all the things. I mean, these mentioned things are done by the script. Otherwise, we are the one who need to set up the each part. Then this is our get update, and then this is install CRIO. I mean the runtime, Docker runtime, or sorry, container runtime. Then yeah, system still daemon reload, enable CRIO, echo runtime install. After this is done, we will get a message like CRI runtime installed successfully. Then enabling and updation of the packages. You see, sudo apt get update by install this version, then update by after small installation we will do one updation. Okay, I mean system updation. That's why it's mentioned in between.
I have a question here, sir.
Yes.
The swap of memory, why we should do that, sir?
Memory swapping means it for example, we are installing an application. Okay, first we configure the virtual machine, then we install the application. By default, yeah, the swap memory is turned on. So if the swap there, it will make some issues. I mean memory issues. For example, some applications need to access more memory. So if swap is enabled, it will conflict, so the applications can't run smoothly. So it will, I mean, we couldn't run the application properly.
Okay, thank you.
Any other doubt?
So this script will be same whenever we run worker node, or we need to do any changes based on the requirement?
No, this is the official steps that we follow when we installing Kubernetes cluster in
Okay,
self-host machines.
okay, thank
So
you.
it's wrap up in a single file and inside a script. That's all. So we couldn't go through each step. Okay, like this is one step, this is the next step, this is the next step, like that. Okay, we inside in all the steps in a script and just run the script. So the script will do the all things. And in this case, the error rate is less. Okay. So I am going to clone that repository. For both. Okay. And cube admin scripts are here. Successfully cloned. CD. Our files, I mean script files are under the script directory. So CD scripts. You see both scripts are there. So the common script we need to run in all machines. So how we run the script? Dot forward slash the script name. So this is why as a developer engineer, we need to learn scripting. Okay. Yeah, both are done. So there is one more script there. That script for master. So I will run the master script in master machine. Only master. So now what happened here is installing the Kubernetes. You can see pull registry, API server, then pulling from queue controller, scheduler, proxy, all things we download the package from the registry. Okay, the registry name is k8.io and installing the packages. Yes, now it's done. Here we can see Kubernetes install created, all things done. Then after we configure, I mean installing the master dot as such inside the script file. I mean the script will install all the things of running a Kubernetes cluster, Kubernetes components, like there is 4 components in master part, right? So all the things installed by the script. Okay. So as of now, we didn't configure, I mean, connect with our worker node. Okay. So there is a API, I mean, there's a link the master will provide. I mean, this master machine will provide. So we need to copy the enter code and paste it in the worker node. Okay. So there is a communication between these two machines, and they know that is the master and this is a slave machine. I mean the worker part. So there is a path for that. We need to go there, and in master part there is a token. Actually, that's a type of token. kubectl. Okay, fine. Before that, we need to check the pod status. Okay, because when we install the master part, I mean master node, inside the master node there is so many components. I mean some services running. That service is also running in the containers. kubectl get pod. Yeah, these are the master part components. Okay, that core DNS, etcd master, kube API master, kube control master, kube proxy, kube scheduler. So we can yeah, say that our master part is done. Okay, so we can check the node part actually. kubectl get node. Yeah, there is a single node. That means the master node. This node is master node and its control plane. That means master part. And only there is only one node as of now. So now we are going to add the worker node. Okay, and we need to check readiness, node readiness. Just to print the token. kubectl token create print token create join token. Oh, sorry. We are talking with kubeadm, not kubectl. Yeah, you see, the command is kubeadm token create print join command. Okay, there is a join command there. That means the joining between master and worker. So this is the joining command kubeadmin starting from Kubernetes to 64. This is the command. So copy, then paste it here. Hit enter.
Taufik sir,
Yes.
is this kubeadmin a product from Kubernetes, or is it some third party guy open
No,
source
it's
creation?
it's part of Kubernetes project.
Ah, okay.
You can see when we add the cluster, this is a message, okay. This node has joined the cluster. That means it's successfully added. Again, I'm going to check node. You see, now it's added. For example, if you add more, then configure other machine and download the common script there. Then copy the same command, I mean the joining command, and paste it to the newly machine. So after that, we will get another worker node, okay. Got it.
Here I have a question, sir.
Hmm.
So if we have a number of nodes, like there will be more nodes, right? More number of other nodes. So that time, this common .sh script, can we run at a time on all the nodes, or we need to run on each and every one?
Sorry.
This common .sh
Yes.
script.
That we need to run in each machine.
So there will be more worker nodes, no? So we need to run on each machine.
I mean, in there is if there is a lot of node, then we go manually. That's the thing, right?
Okay.
I mean, for example, we need to create a Kubernetes cluster and we need to add 10 node. Okay, in a scenario. So the case is we need to log in each machine and run the common script, right? So it's a messy thing. That's the question, right?
Yeah, that's my question. Yeah, that's my point.
Yeah, so in this case, we can use Ansible and add all
Okay.
machines as inventory in a single playbook, create a playbook, and using Ansible, we can push the common SS file in each machine. So we didn't log into the each machine.
Oh, yeah, I understand. Thank you.
Okay.
Actually, can you re-explain like from where you create the token and the other side say this node has joined the cluster? So can you retake that for me because I'm a little bit lost?
Yeah, in master part, there is a token, okay, like say like a API and some details. This is the details, kubeadmin join, and this is the port number. Then 6443. I mean, this is IP. Okay. IP of this machine, I mean master machine, and there is a port 6443. That's 64434 API server. You see 64434 Kubernetes API server.
Yeah, I see that one.
Yep. Then the token, okay, it will create a token, and that's token certificate hash. It's a hash, I mean encrypted token. SHA 256 is encryption code here. Yeah, we will get the token. Then copy the enter token. Then copy, then paste it to the machines. I mean our target machine. We need to make it as a slave of the Kubernetes cluster. Got it?
Yeah, but before this one, you say kubectl token create. So there, I don't understand that command.
Which this command, kubectl token create print join command, right?
Yes.
Yeah, this is we are talking to the kube admin actually. So when we created Kubernetes cluster in a self-host machine, we are going with the kube admin. Okay, Kubernetes is one of the Kubernetes service tool for creating, managing, adding nodes, all the things done by the kube admin. So we just talk with the kube admin to create that print join command. So it will send the things that's under our result. I mean, kube admin this result.
Yeah, okay, I see now. Thank you.
Yeah. So we can just try to deploy a simple application. I think there is an application here. CD. Yeah, like manifest, there is some sample application. Yes, sample application. I'm just deploying the sample application. kubectl apply file. File name is sample app .yaml. Yeah, that's a deployment. I mean, Nginx deployment. kubectl get port. Okay, you see there is two replication of Nginx. Just to check the cat. I mean, now we can maximize the yeah, this is for a simple Nginx deployment. Okay, Nginx web server. And in simple YAML file, the deployment and the service both are mentioned. Also, you see, one is for the deployment, kind deployment, and the next kind is service. So here the service is not port. Okay, the not port IP range is 32,000. So we already enabled the IP ranges. I mean 30,000 to 32,000 something we already enabled. So we didn't go there and manually add this thing. Already enabled it. And yes, not port image is Nginx latest. I mean this is the Docker image. So it will push the pull the image and run the application when we already it's running.
So
yeah,
when you get a first command to create the manifest file with Nginx application, I didn't see, you did not state Nginx. You say when you execute apply, Nginx did not wasn't part of the with the command, but on the manifest file, it was able to create engineers. How did that happen?
Here there is the manifest there for deploying engineers.
Can you bring the first command there with the apply? The kubectl apply with sample with YAML.
Yes.
Yes, this one. And there is no engineers stated, but it created engineers. That is where I got confused.
I mean, inside the YAML, service app.yaml, that is the manifest file, okay? Inside the manifest file, we mention all the things. This is the file.
Yeah, my argument is in case we want to use a different image, we want to use Alpine, we want to use CentOS, we want to use Ubuntu, or then if you want to use the same command, how are you going to use that different image, not engineers? Do you understand my question?
Yeah, I got the question. I mean, when we are deploying with a different machine, right? For CentOS.
No. Can you just scroll and go back and follow the steps that I can explain to you? If you can scroll. Okay, if it is clear, then no. My concern is when you execute the apply command, you created manifest file with engineers.
Yes. Okay.
But if I want to create with a different image, for example, let's say Alpine, and how would I get my Alpine? Because this one you created, it didn't state the image, but the engineers came in the manifest file. That is my concern. How are you going to create different image to the same command?
We already done different. I mean, we already created different.
Can I stop you guys? So probably his question is, instead of Nginx, if you want Apache or something. So I think your common script file has some instructions, what should go on the containers, all those things.
Yeah, got it.
Is that the thing you are asking?
Okay, cat sample.
Here, I will explain. Okay, this is the deployment. Okay, deploying application. That's kind. Okay, then the metadata, the name. This is a single name to mention. Okay, that we can provide any name. So here, for the best way, we can see this is a Nginx deployment. So we just put the name Nginx deployment. Then under spec, some selectors there, we didn't mention anything. Under match label, we mention the app. This is again the name of the app. Okay, that is called Nginx. Give me a second. I am plugging my laptop. Yeah, okay. Yeah, here the main part, okay, under the image is under spec, the container, then the container name and the container image. this image is the same image where the Nginx image belongs. I mean, the same name in Docker Hub. Got it. Just to copy and go to paste here. Click enter. Directly, you can go to the Docker Hub. So this is the official Nginx image provided by Docker Hub. So we pull the image when the container, I mean, when the manifest run, okay, when we apply, I believe we need to make changes to manifest file according so that it deploy whatever is desired. This is a simple manifest file actually. Yeah, this is a thing happening. I mean, this image will pull to our machine, I mean Kubernetes cluster, after applying this manifest. Then the resources, this is the CPU utilization and memory utilization that allocate for the specific application. We didn't bother about these things. As per the requirement, we need to add more resources. That's all. Then the ports, port is 80. Okay, that's a container port 80. Then this is a service manifest. I mean, for the same application, we need to expose the application using service account. So the kind is service. The name is Nginx. Then the selector is Nginx. The app is, I mean, how the service is connected with the deployment. So here where the selector, you see the selector app is Nginx. Again, we mentioned here Nginx. So they have the same name, so they will communicate with each other. Then the type, okay, different types there, cluster IP there, not port there, load balancer there. Cluster IP, if we choose cluster IP under the type, it will only communicate within the cluster. And when we choose the node port, we can access the application from outside the cluster. So in this case, we can access this application outside the cluster. That's why when we open the browser and type the IP, we will get the application. If the type is cluster IP, we couldn't access the application. Okay, only internal access only. But when we choose node port, there is not load balancer. Okay, this is only for the test purpose. We can mention node port here for service. For a production level environment, we need to choose load balancer. So the Kubernetes have the load balancer and it will automatically routing the things. We didn't bother about anything. And
Okay, sir.
yeah, then we
Thank
need
you.
to then we need to expose the container port again here. Target port, the same port. Then the node port is 32,000. This way we access the application using the 32,000 port and the IP of the same machine. Not same machine, the worker machine. This is master machine. And we need to check the application is which machine. Okay, kubectl. Get port. Oh. So you see, this is our in our case we choose replicas 2, means we need 2 pod. Okay, so when we checking the port, we get the 2 port. Inside the 2 port there is 2 container. One container is in a single port and other container is another port. That's why 1 by 1 means there is one container and that container is up and running. That is 1 by 1. If 0 by 1 means there is the container is not running. Okay, and status is running here. And the IP is 192.168. That's internal IP, okay. And the node where the application belongs, the node name is worker1. So we can say our Kubernetes cluster is done and the application is in the worker node 1. Got it? So we can access that.
Now you will learn Maven and you will.
So we can access the application, okay? How we access the application? Just copy the worker node IP, okay? And paste it. Then mention the port number. The port number is 32,000, right? Hit enter. See, the Nginx is live. So I will quickly deploy one more application. So you will get more idea. That's different. Apache, Docker, yes. Application. I missed some application. These are big size application. Also Nginx. Copy. Here we can change the thing, okay? Like if it work, then we can change to not port, because this is self-hosted thing, so not port. Then change the target port. 32,100. File. The file name is test.yaml. If the file is good, then it will create. It's created. Then same way we need to install service for the deployment. We'll check. Oh no, the container is not up and running. See, invalid image. That's why the container is
Is the
not.
Nginx running?
Nginx is running. Nginx is running in port number 32. See, and here we can see that is running. Both replicas are running. kubectl logs. This way we are getting the logs of the running containers. Copy the container, paste it here, TAIL 10. Yes, these are the logs, okay. I mean these are the live logs. Yes, any doubt? Coffee have doubt, right? Previously.
Yeah, it's okay.
Yeah, I think you got the point, right? Or confused.
Yeah, it's okay.
I mean, for deploying different app, for example, we have to deploy 3 application. So we need to create 3 deployment file, 3 service file. I mean the YAML file. And we need to, yep. And each configuration inside the YAML file, we need to specify the, I mean the image, the port number, the name selector, and all the things we need to mention. But coming to Docker file, we need to choose the build things. I mean, when we're creating a Docker file, if the Docker file is for the Java application, we need to add the, I mean, the path of the Java application, copy the thing, then the dependency, all things we need to mention in the Docker file. I think you confused with the Docker file and the Kubernetes manifest file.
Here, like for Docker file, can you show that to me again one time, please?
Sorry?
For Docker file, can you show that to me one time?
Docker file. Yeah, this is one of the Docker file. A simple Docker file.
It's okay. I will retake the I mean the whole class. I mean today class. I will take it tomorrow, and I will have a clear idea on it. I'm okay now. I will retake it.
Okay. You ping me, okay, if you have any doubt. Directly ping me.
Okay.
Okay.
Thank you.
Yeah. So anyone have any doubt? Self-hosted Kubernetes creation is, I mean, much easier using the script, right? So fork the repo. I will share it on chat, okay? Fork it and use it. Clear? If you have any doubt, then we can discuss. Otherwise, we can wind up. Everyone.
Thank you, sir. We have 3 classes worth of pending homework.
Yes, I have some homework, so I will put it on the chat. I mean the group for doing the weekend. And one lab you all are do the CI/CD lab, okay? Our recent is end-to-end pipeline, not end-to-end pipeline. I mean the DevSecOps pipeline. For this lab, I mean configure self-hosted Kubernetes for deploying our next pipeline. We need to deploy in the Kubernetes, okay? Fine. Then we can wind up, right?
Yes, sir.
Okay, then except Kumar present, all of you can leave. I mean, Kumar is you join here. We need to discuss something. Okay. Then good night all.